I'm Joshua Bardwell, and you're going to learn something today because this is the first time in history that I have released the results of my super awesome battery testing. Yeah, remember that battery test thing that I was going to buy like 2 months ago? Well, I finally got it, and I got it set up, and I'm running. Well, this isn't the first official test result. This is the let's document the procedure, but it is test results, and I'm going to tell you about them. Stay tuned. One of the things that I'm known for is testing batteries, testing LiPos that are used on mini quads to find out which ones are good and which ones are bad. But my test procedures, I've never been 100% happy with them. And that's why a couple months ago, I put out a call to raise money to buy one of the best battery test setups you could possibly own, the West Mountain Computerized Battery Analyzer. And this thing has some awesome software to let you run all kinds of interesting tests in controlled ways that I never could before when I was just throwing a big knife switch literally connected to a spool of wire sitting in a 5-gallon pail of water. Yeah, this thing is awesome. And some of you have been wondering, whatever happened to that? That was like 2 months ago. And I'd like to remind you, I told you that the 2 kilowatt amplified loads that they had to make them for me. They don't just keep them on the shelf, but I got them, and I am 100% set up and ready to go. And in fact, just today, I ordered the first few batteries that are going to be in the first officially released test results. But I'm going to show you the preliminary results of that, because of course I didn't just start with the batteries I was actually testing. I've been testing in the last couple of weeks and figuring out, how the software works and how I want to run the tests, and so that's what I'm going to show you, and that will introduce you to the test protocols that I'm going to use. And then when I get these batteries, I'm going to do the first round of actual testing. Isn't that exciting? Now, some of you guys are wondering, wait, you bought the batteries for what batteries did you buy? What are going to be the first ones that you're testing? I put the call out a couple days ago to the people who contributed to the GoFundMe, and I let them have the first vote because I figured that was only fair, right? I am going to put out a more widespread poll after I give those guys a chance to get their voices heard. But you'll be happy to know that the first batteries that I'm going to be testing are the Thunder Power Adrenaline, I think it's 1600 95C and 4-cell, and the Tattoo R-Line, I think it's 1550 95C 4-cell. The two multi-GP race spec batteries, they're also on my Ultimate FPV shopping list. They're two of the high-end batteries that I recommend, and I've bought 2 each of those batteries. I didn't use my own name and address, though. I used a secret shopper because sometimes people notice my name on like, oh, hey, that's Joshua Bardwell, and we want to make sure that these are the exact. Nobody's cherry picking anything. So those batteries are coming in the mail. And I think you guys will agree that, hey, those are probably 2 batteries you'd like to see tested. I'm going to put a link in this video description to the poll where you can vote, because by the time this video comes out, the poll will have been up for a couple days for the donators, and then everybody else can go ahead and get their voices heard. So go down to the video description, click on the link down there, and you can add batteries. You can vote for existing batteries that are already on the poll, or you can add new batteries to the list, and we'll just keep going, right? Show me what you want to see tested. I will do my best to get them tested. I want to talk to you a little bit about the test setup and the test protocol, and I'm going to show you the results of this test, of course. But first, I want to tell you some of the things I've done to try to make sure that the tests are I want you to be able to rely on these results. And I also want to make sure that nobody's going to be able to criticize these results and go, it's bogus. It was all a waste of time. So one of the things I'm doing, I have to figure out how to temperature control the batteries. And what I've done is I've got this electrical, it's like a heating mat. You use them if you're starting seeds in the spring, and you put it under your seed tray to warm the seed tray a little bit. The specific one I've actually got is used for brewing. If you guys out there make kombucha or anything like that, you can put it around your container to warm it slightly. And I've got it inside the bat safe. I tried various things, but I found that inside the bat safe had the most stable and consistent temperature. So I'm just going to store the batteries in the bat safe, and I've got this heating mat in there hooked up to a temperature controller. And I find that with the right container, I had some trouble keeping the temperature stable earlier, but with the right container, with a small insulated container, the temperature stays really stable within about a degree. So I'm leaving the batteries in there. Now, an interesting question is how long to leave the batteries in there? Because the battery has to be not just at the outside, at the surface, at the right temperature, but all the way through. The temperature of a battery really affects its performance. Even just 3 or 4 degrees Celsius, it's a fairly substantial difference, but it can make a big difference in the battery's performance, and we want consistency. So I still haven't 100% figured out how long to leave them in there. I'm leaving them in there 12 hours. I figure, gosh, surely the temperature will have moved all the way through in under 12 hours. It'll be a consistent temperature. I feel like I can get that down a little bit because I notice that when I do a battery test, the battery heats up from the inside first, right? Inside the cells, and then the exterior temperature will continue to rise. And I think maybe we could guess about how long it would take to normalize the temperature of the battery based on how long that takes. It's significantly less than 12 hours. But for right now, we're using 12 hours as the standard for how long the battery has to come to temperature. And that actually is a big deal because that slows down the testing. After every test, I have to recharge the battery and then let it sit for 12 hours, which means at most I can do, well, 2 tests a day, except a little less than that because it takes maybe an hour to recharge the battery. Okay, so what that means is that if I've got 10 or 15 tests I need to do on a single battery to run the whole battery of tests, yeah, I can do basically, it takes me about a week to 10 days to do a test on a single battery. Now, I can do more than one battery at a time, right? But from the time I get the battery and start the testing to the time that I finish the testing, and it takes about a week, a little more. I'd like to see that come down. I'll continue to work on that. But I'm also charging the batteries on the exact same charger every time. And I've calibrated this charger using the K-Moon voltage reference method that I showed in my video about how to calibrate a charger accurately. Now, some of you will object to the fact that I'm using an ISDT charger. You say, well, shouldn't you be using something more precise, like an iCharger? And so that I say, number one, I did calibrate it, and number two, if it's off by a few thousandths of a volt, well, at least it'll be consistent. And I don't think a few thousandths of a volt will really make a difference in the testing, but that's what I'm going with. I've calibrated it. I will recheck the calibration every so often, and I will always use that same charger throughout all the testing, and that's another way I'm striving for consistency. Okay, those are some of the things I've done. If you have any other questions about ways that the tests might be valid or invalid, go ahead and put them down in the comments. I'll do my best to either address them or go, oh, I didn't think of that. And then I'll come up with something to address them. Let's take a look at the results now from the very first round of testing. Well, the negative first, the preliminary round of testing. Let's get into it. And the first test we'll look at is the capacity analysis test. And the purpose of this test is to find out if a battery's labeled capacity is basically honest. These batteries are labeled as 1600 milliamp hours. What we're going to do is we're going to discharge them at 1C. So they're 1600 milliamp hour packs. We're discharging at 1.6 amps. Okay. And then we'll see what percent of the rated capacity we get. Now, another thing I want you to see is that I've chosen a threshold of 14 volts for this test. That's a cutoff of 3.5 volts per cell. Now, some people are going to object to that threshold, especially people who test other kinds of lithium packs like 18650 lithium ion batteries. They're going to say that you're not going to get the full capacity unless you discharge closer to maybe 3.2 or 3.3 volts per cell. But I think 3.5 is a very fair and, in fact, a little bit conservative, maybe a little generous margin for these batteries. The thing is, when you're flying your quadcopter, the battery's you're going to be drawing way more than 1C. You're going to be wearing way more than 1.6 amps from this battery. It's going to sag a lot more, and it's when you're done flying, it's going to be resting close to maybe 14.8 or 15 volts per. So you're not going to get it down to 14 volts under normal conditions. So saying that the capacity analysis is done discharging at 3.5 volts per cell or 14 volts for a 4 cell, I feel like that's pretty generous considering the way that we normally use them. But here's what I'm going to do. I'm going to say that the battery passes its capacity test if it delivers at least 80% of its rated capacity going down to 3.5 volts per cell. And I'm kind of just making that number up, but I'm kind of also basing it on some industry. I looked up some ways that other people do testing, and I feel like that's a fair place to be. I've also based that on, remember, I've done a ton of battery testing until now. I've tested maybe, 50 or 100 batteries before now. And I feel like if you can't meet that standard, then something seriously, like your label's just not right. So 80% rated capacity at 1C discharge. How did this battery do? We can see here that at the moment that the test cut off, the first battery, the green line, was at 1.41 amp hours, and the second battery was at around 1.43 amp hours. So if we just grab our calculator here and check 1.4 out of 1.6, we get 0.875, 87.5%. Both of these batteries easily met their rated capacity, 1600 milliamp hours. The label's rating of 1600 milliamp hours is basically honest and correct. The next thing I started doing then is constant current discharges. This is the 10 amp discharge. And since I've got two of these packs, I tested both of them side by side. One of the things I looked for in this testing is consistency between the packs as well. We'll see how they did. Some of you are going to notice that the temperature lines here are not consistent between them. This battery appears to have started at a temperature of only 19 degrees, and this battery appears to have started at a temperature of like 25 degrees. That is absolutely not the case. Both of these batteries started the test right on 25 degrees within, plus or minus a half a degree. And I verified this, number one, because they were sitting in the box at 25 degrees for 12 hours. They have to be at that temperature. And number two, because I verified it with an infrared non-contact thermometer before starting the test. So what I discovered is that the temperature probe used by the battery analyzer has a really slow response. So if it's sitting out in the room temperature before you start the test, it's going to read 19 degrees. You touch it to the battery, and then it takes a little while to actually come up to the battery's temperature. So I think this temperature sensor is going to be somewhat useful for stopping the test if the battery gets too hot, which I've got it set up to do. If the battery gets over a certain temperature, it kills the test. But as far as validating that the battery started the test at a certain temperature, I don't think it's going to be really useful because it's so slow. And yeah, I don't think it's great for that. So then, setting aside the temperature, let's see how these batteries did in the 10 amp discharge. And we can see that the battery lasted 8.5 minutes at 10 amps discharge, 8.1 minutes at 10 amps discharge, and discharged 1.3 and 1.4 milliamp hours, or amp hours rather. Now this graph is very interesting, if a little confusing to look at. I want you guys to just ignore these dashed lines. These dashed lines are the temperature readout. I don't think there's a way to remove them while leaving the other traces. So just ignore the dashed lines, pay attention only to the solid lines. What you're seeing here is a discharge of the pack at 10, 20, 30, 40, and 50 amps. Okay, so these lines, this is the 10 amp line. And what we can see here is, well, in this graph, we can see how long the battery discharged before hitting that 14 volt threshold. And we can see at 10 amps, the battery discharged for, discharged for 8.5 minutes. At 20 amps, it discharged for 4 minutes, 4.1 minutes. At 30 amps, it discharged for 2.6 minutes. At 40 amps, 1.6 minutes. And at 50 amps, only 0.9 minutes. Now, when I started this testing, I kind of didn't know, I kind of still don't know what the final criteria would be to stop testing a pack, just don't go any further. But it seemed really clear to me at this point that there was no point in continuing to just do this exact same test at higher amp draws. At 50 amps discharge rate, the battery gave less than half its rated capacity. It gave about 700 and some odd milliamp hours. And when it rebounded at the end of the test, it rebounded to 15.3 volts, which is darn close to the resting voltage that I want batteries to be at. I like my batteries to be around 15.0 to maybe 14.8 volts, 4-cell batteries, obviously. When I'm done flying them, that's what I think is healthy and safe and keeps your batteries, giving more. So 15.3 volts resting is not quite a full discharge, but it's a fair chunk of a full discharge. So I feel, if we go to 60 amps, I can kind of see where that's going to go. And apparently I didn't save the results of that test. I don't know. When I open the file, I just get a blank screen. So we'll move on. Here is a 70 amp constant current discharge. Yikes. You can see that at 70 amps, the battery barely made it to the end of one 5-second pulse. It nearly hit 14 volts, even on the first pulse. On the second pulse, it just barely didn't touch 14 volts. And on the third pulse, it touched down. So we really, whether you draw the line at 50 amps or 70 amps, we really clearly are hitting the limits of this battery's performance, at least by these standards, using the 14 volt cutoff. Now, there's one more test that I did that you guys are going to love. You see, I want to test these batteries at their rated C rating. And this is a 95C battery, 1.6 amp hours. It comes out to something like 150 amps and change. It's actually 152 amps exactly. Now, unfortunately, my test only goes, my $4,000 2 kilowatt test rig maxes out at 120 amps. But I think you're going to see that doesn't even freaking matter because, so I ran a test on the battery at 120 amps and here's the result. Now, as you can see, even though I have the test set to cut off at 14 volts, the battery continued to sag a little bit and cry until it turned around and recovered when we drew 120 amps from it. How long did it take for it to get to 14 volts at 120 amps? It took 0.03 minutes. That's data point 20. 0.03 minutes. Let's just do the math here. I think that is 1.8 seconds is how long it took to get down there. So at 120 amps, it sagged to 14 volts in 1.8 seconds. And some of you are going to say, hey, that's still flyable. I don't mind that. 14 volts. Hey, you know what? Mine sags down to like 13.6 volts. And I'm okay with that. I still consider that to be a pretty good result. Well, we will see if that's a good result as we get more and more tests in. But I said, okay, you know what? I've been watching some racing. I watched some of the replay from Sebring and the multi-GP race down in Sebring. And a lot of those guys, their batteries are down in the 13 volts pretty much from the minute they hit the throttle. And they're using, I know some of these guys, they use absolutely brand new, fresh batteries for these big races. These are quality batteries. So maybe 14 volts isn't realistic. And I said, okay, let's try a different threshold. In this test, I used 12.8 volts as the threshold. And I thought, there's just no way anybody could argue your battery should be sagging below that under normal conditions. And how did that go? We were discharging at 120 amps, and it took 0.05 of a minute. Three seconds. So what conclusions can we draw? Well, first of all, I'm going to remind you these batteries were sent to me by the vendor. I did not do a blind buy on these. If you feel that affects the results, if you feel that they might have been cherry-picked or in some other way not be realistic, you need to take that into account. But in what world is 95C even a thing? And this is a Pyro-Drone battery, and I hesitate here a little bit because Pyro-Drone is awesome. Okay, PureFlip, Pyro-Drone, what's the difference between those two? I don't know. They're an awesome vendor, and they sell quality stuff, and I feel a little bit bad that they got to be they sent me the batteries. They kind of wanted me to test them. So, hey, you're first up on the line. But what does 95C even mean in today's world? If we pull 120 amps and we hit 14 volts in 1.2 seconds, and we hit 12.8 freaking volts in 3 seconds, and that's supposed to be a 150 amp rated battery. I don't know how long you have to deliver 15 amps in order to be like a 95C rated battery. What is it? I think we're going to see a lot of this as we go on. that the C rating for the batteries is going to just be complete nonsense. And what I'm going to do is I'm going to figure out the standard that I want to use. Maybe it's going to be 50% of your milliamp hours or a 5-second discharge. I'm going to figure out what that standard is going to be, and I'm going to give you guys the tools that you need to be able to compare the batteries to each other and see which ones are the best. I think we're going to find that the C rating on the label, I just don't even know what it could possibly mean in real life. So there you go. I hope to have the very first actual batteries for testing in my hands in about 3 or 4 days. They should ship tomorrow, probably today by the time you're seeing this video. I should have them in 2 or 3 days after that, and I should begin the testing. So I would guess that in about 10 days, you guys are going to start seeing the actual results from the first actual tested batteries. Those of you who made donations on the GoFundMe, I promised to give you guys early access to the results, and I definitely am going to do that so that you guys can start snapping them up if they're good results and you want to go ahead and buy them. Hey, that's one of the benefits I promised to the people who actually donated, but everybody else is going to see the results very soon after. Let me know what you think of this. Let me know if you think there's things I could be doing better, if there's tests that I could be doing that I'm not doing. Oh, hey, speaking of that, what about the actual, like I promised that I would get black box data from a real pilot, and I would use that, I would replay that through the test machine, which I totally am going to do. So Evan Turner, Heads Up FPV, I asked him if he could please get me a recording of some of his laps from Sebring. And unfortunately, he was a little too busy trying to win the race. I don't know if you guys saw this, but he had a false start going into the finals, and he was penalized 1 lap. So he started the finals at -1 laps and essentially had to lap the whole field in order to win. And he very nearly did it. It's a freaking heroic thing. I mean, he didn't win, and congratulations to the winner. It's a fair thing. You get a penalty. Hey, but seeing him come from -1 lap nearly everybody in the whole field and nearly come back and actually win with such a deficit is amazing. But unfortunately, he was too busy going through all that nonsense to actually record the black box for me. So we're going to get together and he's going to record some black box data for me. And I don't think anybody could question that it is the data of like a really top racer. If you don't know, Heads Up FPV, Evan Turner, definitely check him out on YouTube. He's insanely fast. He's unreal. So yeah, that data is going to be coming, but I don't have that yet. So that's why you're not seeing that today. That's going to do it. Thank you guys for sticking with me through the end. You nerds, you love numbers. I know you do. Happy flying, everybody. Happy battery testing, everybody.